first say hi to everyone. And it's really, really exciting because I've been talking about federated learning and that we would be able to do something really significant here for a long time. And I'm really excited to show you this demo. Actually, Roy will show the demo. To put things in context, we split the meeting into kind of two parts. The longer part, the first part, will explain and demo federated learning and how we enable it with EdgeLake. And in the second part, we'll introduce actually 4 companies that are integrating their solution with EdgeLake. And we'll go over some of the highlights of each project. And later, in some other later meeting, we'll show a more detailed demo of each one of those projects and how they're leveraging EdgeLake. Just before I let Roy start, I want to say thank you to Win.io, to Nicholas, who's here, and he'll talk later about his project. But the reason is that we're using a live data and a live use case that Win.io is doing with EdgeLake. So we're really excited, and thank you, Win.io, for that. And from here, I let Roy take over, and he will take you through the story. So go ahead, Roy.
So hi, everyone. My name is Roy Shadman. I'm a TSC member for EdgeLake and also an AnyLog engineer. So quickly, let's read the LF antitrust policy notice. Linux Foundation meetings involve participation by industry competitors, and it is the intention of the Linux Foundation to conduct all of its activities in accordance with applicable antitrust competition laws. It is therefore extremely important that attendees adhere to the meeting agendas and be aware of and not participate in any activities that are prohibited under applicable U.S. state, federal, or foreign antitrust and competition laws. There's some examples on this link here, and if you have any questions, please look at this link. So today's topic is really exciting. We're going to show how you can enable federated learning really easily with EdgeLake. And so the agenda will be an introduction about EdgeLake and federated learning, why it matters for AI at the edge. Then we'll talk about current challenges in federated learning and what are the key obstacles that currently limit its adoption. And we'll show how we can close the loop using EdgeLake to deploy federated learning in a very seamless and easy way. I'll then go into a live demo, and I'll show you a practical implementation of using EdgeLake with federated learning. And then finally, I'll conclude and we'll go into a Q&A open discussion, and we'll talk about some of the next and exciting steps we're taking with EdgeLake. So for the people on the call who maybe are not too familiar with EdgeLake, I'll talk about how we're creating a paradigm shift at the edge. So today we have a lot of sensors at the edge. For example, we have cars, oil rigs, security cameras, solar panels, and all these edge devices are creating data, and this data is being sent to edge nodes. We have applications that want to query this edge data, but because there's no way to get all this data in a unified way, everyone has to send this edge data from the edge to the cloud. We have a full data transfer to the cloud. Once this data reaches the cloud, it can be organized in a database, and then AI applications or other applications can make control decisions using this data. And then these decisions have to go back where those edge devices are. EdgeLake on the right side here has the same setup. So we have these edge devices and they stream data to edge nodes. But this is where the data stops moving. When you have an application that wants to access this data, the application just needs to send its query to any one of these edge nodes. The edge node figures out where the relevant data is. So for example, which edge node has the information I'm seeking. It ships the query to the edge node and then unifies the result set that it gets back. So the paradigm shift that we're really summarizing here is that today, data has to move to where the queries are executed, and that is in the cloud. What we're doing is we're letting data remain in place at the edge on the edge node, and we're bringing the query to the data. And this just allows us to send the query over the network and the result sets that satisfy the request by our applications. So as you can see, this our setup, our distributed virtual setup, has very good we can really utilize it with federated learning. So quickly, what is federated learning? The best way to understand it is to understand how centralized learning is done first. And I took this figure from an Intel project called OpenFL. And how centralized learning works today is that you have multiple entities.
Just a second, Roy. Can I ask participants to mute themselves? Because I cannot mute everybody and there is some background noise. Thanks.
Oh, thank you. So again, this figure is taken from an Intel project called OpenFL. And the key way to understand federated learning is to understand how centralized learning works and then how federated learning takes advantage of the decentralized aspects of data today. So in centralized learning, we have multiple entities. We have hospital A, hospital B, and hospital C. And to run some machine learning algorithm on this data and in a collaborative way, all the entities have to centralize the data to a centralized infrastructure. So what the key point to take here is that the data has to physically move to a centralized location. And once this data is in a centralized location, such as in the training infrastructure that is built, then we can create a machine learning model that each entity can use. Federated learning, on the other hand, provides a way for each hospital to independently create a submodel of the model that we are aiming to create. So hospital A creates a machine learning model, hospital B creates a machine learning model, and hospital C creates a machine learning model. Each of these models is being created using each hospital's independent data. Now, once these models are created, only the model moves to an aggregation server that is shared amongst all the entities. And once this centralized aggregation server receives all the models, the aggregation server fuses these models into one model and then provides the model back to each entity. So what I'm showing here is that only the models move, the data remains physically in place at each entity. And again, just to show, this is really, it's synergetic with how EdgeLake operates. Data remains in place and only the queries move to the edge nodes where the data is. Here, in EdgeLake, only the models move across the network, not the physical data. So a key overview of federated learning is that everything is decentralized. So model training happens on local devices instead of a central server. And this allows, and then one of the key overviews that this enables is that it allows you to ensure data privacy and security. And this is offered because raw data remains in place. Only model updates are shared between all the participating nodes. This also allows you to be efficient and scalable. And so there's no data transfer. Only the model parameters are moving. Physical data, which is the big chunk of the data, stays in place. And it also allows you to scale horizontally. So if you want to have more nodes participating in the training process, you can just deploy more nodes and that data on those nodes can be used to facilitate model training. Another key point with federated learning is that it allows for continuous learning. So rather than having to restart model training every time you get new data, you can use the previously aggregated models to adapt and retrain based on local user behavior in real time. And so one of the key use cases where federated learning is really beneficial that I want to highlight is a machine builder who wants to collaborate with machine operators who are its customers to utilize all the data to create a predictive maintenance machine learning model. So again, it allows multiple entities to collaboratively reap the benefits of a lot of data and machine learning all at the same time. And this also allows no one to have to share their private data with each other. So now you might be asking, why hasn't federated learning been adopted? And one of the key benefits of federated learning is decentralization, and everything is decentralized. But this is also a key point why it hasn't been adopted. And the reason is that there's no efficient method to operate on distributed data. Like today, all the data has to move to the cloud before we can even query it. So how can we even create machine learning models in a decentralized way today? Another key challenge is the dataset heterogeneity. Everyone has potentially different schemas with their data, and so there's no efficient method to unify distributed data in a seamless way. Another key challenge is that participants are also heterogeneous. And so there's no efficient method to orchestrate many participants and entities in a unified way. And even if there was a way, you need skill sets from across the entire tech stack. So you would need distributed systems engineers, networking engineers, database engineers, cryptography engineers, and machine learning engineers. All these engineers would have to work together to build a federated learning pipeline and process. And then the final reason why the operational complexity is really challenging is that the infrastructure is highly distributed. You have to figure out how to distribute the models. You have to figure out how to aggregate those submodels that each entity is creating. And then you have to figure out how to deploy the federated learning algorithm on each device. And then you also have to figure out how to do the continuous learning aspect of that is a key benefit of federated learning. And while this is easy in a small use case, imagine if you want to do this for 100, 1,000, or 10,000 nodes. There's no efficient way to facilitate federated learning today. And so what I'm going to show is that we can resolve this current gap, and we can do that through EdgeLake. And the key concept that I want to take is that EdgeLake makes data available anywhere, anytime. And we're going to take advantage of this property to do federated learning. And one of the points that I want to come across today is that today our focus is and our demo is going to be on detection and predictive maintenance. And in the future, we're really excited to start looking into how we can use our platform and our framework to do generalized LLM and SLM training, so large language models and small language model training. And this is a really exciting opportunity for EdgeLake, especially given all the recent focus at the edge and NVIDIA's new Jetson Nano GPU that just came out a couple weeks ago. So I'm going to show you now how the federated learning pipeline works with EdgeLake. So say I have my EdgeLake node. I'm going to just publish a training application on the blockchain. The blockchain is a shared metadata layer that each EdgeLake node has access to. And for people who don't know about the shared metadata layer, what it is essentially a shared drive. And you can think about each node has access to the shared drive and all the contents within this shared drive. So my EdgeLake node is going to publish a training application. And then each EdgeLake operator node that has the relevant information to facilitate the training that I'm intending to run has a local database management system with this respective data. And then it'll pull this training application onto the local node. And then once this happens, all the nodes that have this relevant information that will be partaking in this federated learning process will also pull the training application. Then my node will initiate a start training message onto the shared metadata layer. And this will result in every single EdgeLake operator node with the relevant information and that has the training application to start model training. And this model training happens on the data to their local database management system. And so the first node will publish a submodel called model A, and then the second node will publish model B, and the third model will publish model C. Now, these models will then be pulled by the aggregator node. For example, in this diagram, it's my EdgeLake node that is running the model training. And with an aggregation app on this node, I will create a unified final model that I will republish back to the shared metadata layer. Now, this final model can then be a source for an inference application that's sitting on each EdgeLake operator. And these nodes will then pull the final model into the inference application sitting on these devices. And now when data comes into these nodes, we can run inference and create outputs. And these outputs could be control decisions. Should I increase the temperature of the air conditioner, or sorry, decrease the temperature of the air conditioner, or manipulate my oil rig or whatnot. But essentially, the inference happens on the edge node directly. And the claim here that I'm making is that all you need to do is publish the training application on the shared metadata layer in EdgeLake, and EdgeLake will automate the entire federated learning process dynamically. And so this is a good transition now to what I'm going to demo. And I'm going to demo what our goal. I'll first talk about what our goal is. So our goal is to do a temperature prediction application. And the goal here is to optimize energy usage in a school in Sweden. So the school wants to optimize the air conditioner and heating system to save money on energy costs. And so the setup for our demo is going to include 3 EdgeLake operators and 1 aggregator. And I want to point out that this aggregator could actually be any of the EdgeLake operators. So it's completely transparent and synergetic. Any node in the network could be an aggregator. In this demo, I'll have a designated aggregator node. So the data that we're going to utilize has 6 features. The first feature is actuator state. Then we'll use CO2 value and event count, humidity, switch status, and temperature. And we'll use these features to train an LSTM model. And again, this data is also a real world use case data. And this was provided to us by our partners at Win.io. So thank you for providing the data. I'll quickly show you the pipeline of how the demo is going to be facilitated. So the first step is we're going to publish a training application onto the shared metadata layer. This is the only manual step that you need to take. Once we'll initiate a start message as well, each EdgeLake operator will query the data and generate the submodel. It'll then automatically publish the submodel back to the shared metadata layer. And then our aggregator node will pull these submodels, aggregate them together, and then publish a final submodel. But because we also want to show continuous learning, we're going to show steps 2, 3, and 4 happening over 5 cycles. So we're going to do 5 rounds of training. And then in the middle of these training processes, we'll also execute some edge inference directly on those nodes. So I'm going to set up the demo really quickly. If anyone has questions, feel free to ask.
Yeah, we're going to do questions at the end. But if you've got a question you wanted to address now, go ahead and put it in the chat, and we'll try to address it either now or at the end of the presentation.
So I'm going to go back a little bit in the slides, and I'll walk you step by step on this process. So first, I want to show you that we have So first I want to show you, oh, sorry. I want to show you our test network or our network. So when I have an EdgeLake cluster.
Can you increase the font a little bit, Roy? Thanks.
Yeah.
Okay.
So when we have an EdgeLake cluster, I can issue the command test network, and this will evaluate our network. So it'll tell you exactly how many nodes you have, what their IP addresses are, what their roles are, and what the status of these nodes are. So we can see that we have four nodes running, and this is good. So this means we have 4 nodes. We'll have 1 aggregator node and 3 operator nodes. And these nodes are all utilizing the shared metadata layer that I showed here. So in my demo on the right here, let's go to that. In my demo on the right, I have Postman up here. And I'm going to use Postman to publish the training application. I'm going to publish the training application, and then I'll initiate another message to start the training. And then training will be dynamically facilitated. So to start the training, it's 1 click of a button. And now this model is being published to the shared metadata layer, and each of these nodes will dynamically pull this training application. So we can see that each node took the model from the shared metadata layer that I'm tracking. And we can see that that node 3 successfully initialized, and node 2 also successfully initialized, and also node 1 successfully initialized. So now that the training app is sitting on each of these operator nodes, I'm going to initiate the start training message. And again, this is just one simple request. So if we go to the aggregator node, we can see that the start training round message was initialized, and we can see that this node 2 was the first to receive this message, and it just ran one round of training. And so we can see on step 2 that the model training was done, and then the model parameters were published. So essentially, it ran the training on the data local that's on the local DBMS of this node, and then it published this model to the shared metadata layer. Now this model is going to be pulled by the aggregator node, and we can see that this aggregator node received the parameters, it aggregated them together, and then it published the final model back to the shared metadata layer. So we started having this pipeline. And one of the features in EdgeLake that we built is that you can evaluate your model training dynamically at any point in time. So I can run an evaluation on the model training. And we can see here that on my first node, we can see that I sampled some predictions of temperature predictions. So we can see that given the current model on this node, the input of 20.5 degrees Celsius for temperature results in a prediction for 2 hours later that the temperature in the room will be 22.5 degrees Celsius, etc. I can also evaluate like the mean average of the model. So we have some data that is held out of model training that we use to evaluate the model. And currently, this model is sitting at 75% accurate. So what we're seeing here is we're seeing on the left screen now is that the model training is at round 4, and we're having this continuous learning cycle. So each node is participating in the model training. And I can evaluate the model training on each of these nodes as well. So going back to the slides really quickly, we can see that what we're executing is we're executing this full cycle over and over again. And really the cycle is steps 2, 3, 4, and 5. It's fully automated. The continuous learning is happening. And we can always at any point in time run edge inference. One of the things I want to show is early on in the model training process, the model was 75% accurate. And if we continue in another training round, we can evaluate now that the model improved its accuracy to 83.5% accurate. And this is all done based on the aggregation of these submodels. So now we can see that we've just finished round 5 of training. The aggregator node just is about to finish aggregating round 5, publishing it back to the shared metadata layer. And then these nodes will pull this model. And we can see that the accuracy is improving. So for example, on node 2, we had an 89% accuracy level. And at the end of training, we are sitting at 93.6% accuracy. But now just analyzing the accuracy of the model is one thing, but we also want to use these use the inference to make control decisions. So I can issue inference directly on these edge nodes. So this is my operator 1 node. I can issue an inference directly on this node. We'll see that the prediction was 21.29 degrees Celsius. And we can see that the input temperature was 20.12 degrees Celsius. So our prediction on this input is that in 2 hours, the temperature will increase by about 1 degree Celsius. And if we look at the node itself, we can see that it logged that it ran an edge inference directly on the node. And we can do this across each operator node. So we can run inference on the second operator node. We can see that given this input, our prediction is that temperature will decrease by about 0.5 degree Celsius. And this inference ran directly on the second operator node in step 5 of our cycle. And finally, I'll also show it on the third operator node. So our input is 20.694 degrees Celsius, and our inference in 2 hours that the room will drop in temperature by about 0.6 degrees Celsius. So what I just showed was a demo on federated learning and continuous learning using EdgeLake. This entire process was completely automated. All I did was I published the training application. I told the nodes, let's start training. And then step 2, which is the nodes each queried the local data on their nodes. They each generated a submodel. They each then published the submodel to the shared metadata layer. And then the aggregator node aggregated the submodels, published a final model onto the shared metadata layer, which was then pulled back by each of the operator nodes. And then this cycle happened over and over again 5 times. And then within this cycle, I also ran edge inference, which was completely automated and dynamic. So that was our demo, and I think it's a good time to transition to Q&A about the demo.
Hey, good morning, Roy. Can you go back to your architectural diagram? I think one of your slides had that. And so this was deployed by the EdgeLake as a operator node or worker node, but it doesn't show which elements are data producers and how operator node collects the data. Because in order to realize efficiency or cost saving, you really need to know the whole data pipeline, how many elements are involved, where data is stored, whether data is stored on the producer, or you bringing in another node like this operator node. There's always a marginal cost, and you want to compare that against marginal costs of alternate model where data may be going to a centralized place, cloud. So can you talk about it? What's the efficiency there?
So Mark, do you want to talk about how we get the data from the producer to the operators?
Yeah, it's an excellent question, Mudasar. So what's interesting is AnyLog doesn't necessarily support direct southbound interfaces to data. So effectively, we leverage a variety of mechanisms to collect the data from southbound devices. We'll work with partners that actually collect the southbound devices, and such as a PLC that collects that southbound data, and then they can reference the inference to do the control on that. Effectively, because we're distributing the data close to where the southbound interfaces are, those nodes, I can have a single node aggregate data from 4 or 5 or 6 different southbound devices, PLCs or other applications that are collecting data from PLCs. When that occurs, that data gets pushed into AnyLog, and then the training begins. Does that make sense?
No, I understood that part. I'm just trying to see where other than the truancy or time relevance of data, because closer it is from the data producer, the fresher the data is, right?
Correct.
So that I can see. But in terms of overall cost efficiency, centralized model versus distributed model, it seems like I used to have one database collecting all the data and I could do my training. Now I'm going to have 3 nodes deployed.
Yeah, let me take this question, and the approach here is that rather than centralizing the data, you keep it locally, and you manage the data in a completely automated way. So bringing the data, if you're comparing it to the cloud, you've got the cloud cost. So if, let's say, it's a wind farm somewhere, you sometimes have to even move the data through Starlink, which is very expensive. But regardless of how complicated and expensive it is to move the data to the cloud, you then need to host it on a database in the cloud. So if you use Snowflake or any of the cloud services, database services, there is a huge cost associated with it. Every I/O you would pay for it. Every query that runs has a cost associated for it. Here, these costs are completely gone. So we're talking, and we'll be happy to share with you, we could take it offline. We're talking about a cost which is more than an order of magnitude smaller than the cost of centralizing the data and running those types of processes in the cloud. The other thing, which is super important, I mean, we're talking about data that is in the edge, right? And in most cases, you want to have kind of real-time predictions. I mean, if you're directing traffic, you don't want to do it with round trips to the cloud. It would be too late. So I think there are plenty of reasons to do it, keep it at the edge. And one of the main reasons is a huge cost savings.
I would also add to that in many use cases, there is already equipment close to the data that's collecting the data from instrumentation, whether that's PLCs or other devices. So that equipment cost is already there in most use cases. So we could leverage that to do the model training without having to push that data into the cloud to centralize it.
You don't have to justify it. What I was hoping that in these kind of demos, somebody brings in comparative analysis where you could say, assuming the data is already at the edge in some form or shape, additional cost would be to deploy an application that does the training, right? That I didn't see in this demo. Otherwise, I know Moshe has presented something similar previously, and we've been working sort of together to push this model forward. But I think it will be helpful when you compare, for example, the freshness of data due to round trips or collection analysis tabulation. You could compare data being on the edge versus in a centralized location. That's the time efficiency or freshness of the data or the data quality in terms of resources needed, edge versus centralized location. I think that sort of runs through your head when you're trying to do ROI for making a change. And I don't see that. Technically, I see, all these values, but I can't say if I spend $50 million to move from one method to an alternate method, what am I going to gain out of it?
Yeah, it's a very good point. Honestly, this was a technical demo. We'll take that feedback back when we, further the marketing effort and, look at, those cost savings and how they can apply in real world scenarios. So very good point.
Yeah, I like the idea. I think I followed what Roy was doing there, and I can see it's very translatable, right? It doesn't matter who the data producer is. The data producer could be a router switch, or it could be a 5G base station.
Yeah.
A lot of these things require optimization on a continuous basis, especially spectrum management in base station or cell tower.
Correct.
They continuously require updates and optimization. And if it can be done locally, if anybody who attends Open RAN Alliance specification, they've already created a radio intelligent controller, basically optimizing at the edge. But then you also have to kind of look at a lot of this stuff is going to happen in twofold, one locally, one centrally, as like architecture dictates. Similar use cases can be in other industries too, like mining and so forth.
Yeah, I think we could take the cost issue offline, and I'm sure I could show we could show the huge cost savings in this approach. What we are focused on this demo was to show, so federated learning was considered as something which is great, but very hard to implement and to deploy. And what we were focused to show is that federated learning is really easy with EdgeLake. That is something that can move from theories and academia to the real world, because here is a way to make it something very simple. All you have to do, what Roy was trying to say, is all you need to do is publish a training application, and federated learning could be deployed without the need to bring all those experts. So that was the main point that we were trying to bring, but obviously be happy to discuss the cost issues and what we think is a huge win also in that front.
Moshe and Roy, this is Flavio. Can you hear me?
Yeah.
I have a couple of comments and a question. First of all, great progress. It looks like you did not take vacation over Christmas because
no.
this came.
Yeah,
this is beautiful, and there is one variation on this theme, which is probably not federated learning per se, but is distributed learning, where following the model, for example, of Ray, the project Ray, AnyScale, out of Berkeley, you can take a large model and divide it into smaller models with and send it to distributed workers with different data coming in, like here, into each of those. So they have a technology to distribute training into smaller nodes like this, and is not exactly federated learning. So it's just a variation, but the model is not the same going into each of the nodes, but it's a different part of the model. It's a different slice of the model. So I'll connect you to those guys if you don't know them already.
That would be great. And what I want to say is that, just to be very, very focused, we're not telling people how to do the models and how to run them. We're just showing them a platform where they could automate it and make what Roy was showing in the previous slide. You need experts with all those domains. So we're saying no longer, if that's how you want to operate, here's the platform that you could.
Exactly. What I'm saying is you enable exactly this other model, driven by this Jon Stoika and the students. Jon Stoika is one of the founders of Databricks. Mm-hmm. So I'll create the link. But this is fantastic.
So I want to oh, sorry, Flavio.
I was going to interrupt.
I want to step in really quick. I want to get to everyone's conversation. So is it okay if we take Flavio comment offline?
Yes.
So I want to acknowledge the people in the chat really quickly. So Limor, you asked, are you still on the call? So Limor asked, hi, thank you for joining. So you asked about what's the benefit for multiple entities, for example, in a hospital. So a hospital can't just share their patient information or their patient data to other hospitals. There are laws and regulations about that. So in this specific use case, the hospitals can agree on what the training application is. For example, a common one was during COVID was how effective is the COVID vaccine? So they could each create a submodel based on their own patient data and then collaboratively create a better model. And why you want to do this is because doing federated learning in this aspect allows you to have a model that's trained on more data than the data that you own yourself. So that's one of the reasons why you would want to do this in a hospital setting.
Yeah, and the second reason that is that if you want to create a model that is based on information in multiple hospitals, you have to centralize the data. going back to what we've discussed before, this could be really expensive and very complicated because there is a lot of data involved. The data is not unified. This could be months and months, sometimes years of projects, not to mention the cloud costs here.
Right.
Yeah, and then
So I think what I was,
oh, go ahead.
would you mind? Do you mind if I quick? So I think what I was also wondering, I understand all of that, and I see the value. I think one of the other questions though is, okay, great. So basically we've crowdsourced a model. One, how do I know that the other models that are being brought into this are, I know I'd see that you can see the code, but like, how do I know that they're the right models? Like, how do they know that they're going to lead in the direction that I want? So is there a lot of conversation with the other hospitals to make sure that we're all developing a model that is right, that's going to be right for aggregation, number one? And number two, is there a way then to extract that supra model and bring it back just to my data, not everyone else's data once that model is created?
Yeah, so I'll answer that quickly. So here I showed that we have 3 models published. Let's say these are 3 hospitals, and then the aggregation app pulls these models to itself and then aggregates them together. So you can choose to let's say the third hospital doesn't have good data. You could exclude this model from the aggregation step if you wanted. But this is very like application specific, and it would be up to your use case. So you will have full control of how to do the aggregation and whose data.
I see.
Yeah.
Okay, so basically all these entities are offering up their data and their models and stuff like that. I can pick and choose what I want and see what the results are and adapt accordingly.
Exactly. And you can always roll
Okay.
back, as the models are on the shared metadata layer. You can always roll back the model by saying, I have a starting model, I aggregated it with these 3 models. And then let's say I don't like where that model went. Let's say my accuracy of the model for my data just drastically reduced. I can roll back and try a different combination if I wanted.
Okay, perfect.
Yeah,
Thank you so much.
And Randy
One
had
other-
a question about monitoring CPU, GPU, and whether edge nodes can opt in or opt out of the learning models. So can we address that?
Yeah, I was about to. So that's a great question. So yes, you can, and you can specify as a policy. So you can specify rules of how you want the training to happen. So if you say I have 2 big operator nodes and 1 small operator node, and you only want to run training on 2 operator nodes, you can do that. If you want to use GPUs, so we're building a framework that facilitates federated learning. You can decide to write a training application that leverages the local GPU of your operator node if the operator node has a GPU on it.
Yeah. Roy, I think we want to pause here the questions because we want to be respectful of the time and finish at the top of the hour, and we still want to give the partners an opportunity to talk about their projects. So we will be happy to take all the questions offline. Feel free to reach us up to us, and we'll be very interested to continue the discussion. But please, let's move on.
Sure. The short answer is you can use GPUs at the edge, and you can do that.
And Lazelle, before we jump to that, there was a comment about node hardware requirements. One of the beauties of the EdgeLake product is that it is hardware independent, and you can scale basically based upon the device collecting the data. So as Roy was suggesting, there may be smaller nodes that only collect data, but it will ship the data to another node, or actually it doesn't ship the data. The other node can then request that data to do training on it. So all that's built into the capability of what we're talking about here. Our nodes scale from large servers down to even switches or routers to do data acquisition.
Cool. So thanks for all the questions. If people have questions, please feel free to reach out to us, and we're happy to set up calls next week. So I'll quickly summarize the challenges that we resolved. So a key challenge in federated learning is that the data set is heterogeneous, And that means that essentially data could have different schemas and different types. And EdgeLake resolves all this through a virtualization software that makes all the edge nodes appear as one single unified machine, even though the data is distributed on multiple edge nodes. The data remains available using EdgeLake data services. So our data services provides availability. You always own your data with EdgeLake because the data remains in place on the edge node that you control. Privacy and security. These EdgeLake services have cryptography. We use cryptography for these guarantees, and there is policies that define what nodes have access to what data in your edge node cluster. Rather than needing a bunch of different skill sets from data management to cryptography and things like that, you only need an ML engineer to publish a training application to the shared metadata layer, and EdgeLake automates everything dynamically. Regarding data movement, data remains in place on the edge node. There's no data movement that needs to happen. And the operational complexity is completely self-managed using EdgeLake and very easy. So with that, I'd like to pass to Moshe for the acknowledgements and announcements.
Yeah, so yeah, thanks, Roy, for a great presentation. And you know, this is the first time that we've showed it, and we are putting continuous effort into it, and we'll be happy to share more presentations as demos as we moving forward. We should mention we are bringing it to the market and to use cases, and a lot is done with our partners. So from here, I want just present some of the partners that are working with us and integrating into EdgeLake. And so I let them present their maybe the highlights of the work that they're doing. And as I said, in the next meetings, we'll schedule with them, and they will show a really, really cool implementations and use cases that they're building, and we'll have sufficient time for each project to present and do a detailed demo. But let's start now with Win.io. Nicholas, he's also the data and the use case of that Roy was demonstrating was coming from Win.io. Is Nicholas?
Yes, hello. Can you hear me?
Yes.
Awesome. No, thank you so much. Learn every time I attend these sessions. So yeah, my name is Nicholas Word, based here in Sweden. And I think like the reason, and my background is innovation and strategy, worked with smart buildings for the last 8 years. Well, actually, I worked with dumb buildings for the last 8 years, trying to make them smart. And I believe that now, you know, I attended this Ericsson seminar 6-7 years ago that said, you know, edge is, you know, the up and coming or down and coming, you know, aspect to put data in. And I've been really edge native strategies for a long while. And I think now in Sweden and Europe, we have this NIS1 and NIS2, which are cybersecurity, you know, frameworks and regulations. So they put it really an emphasis on, you know, owning and controlling the data flow. And for today's buildings, it's really fragmented. You basically relinquish data to 10, 20 different apps, and then you're trying to figure out how to bring it back and actually pay for it. So I think like this use case with federated learning is absolutely phenomenal. We started it last year, even, you know, without even knowing about EdgeLake or AnyLog. And I think when we had the call with Roy, he basically said that, well, that's really great, right? Because we started exactly with the same frameworks that they were using. So on my side, it's all about security, bringing intelligence down to the edge. And as my mentor, Ken Sinclair, who's a heavyweight titan in the smart building space, he said, you know, making buildings aware of what they need to be aware of. And I think that's really important. So we have a wireless mesh stack, leveraging now open source. And I think this is amazing that federated learning becomes more of a feature. I think that we saw that on the previous slide. So reducing a lot of the complexity and then using AnyLog and EdgeLake, you know, as the foundation to scale up from here. So I would love to take some questions, or I can rant about this for a long time. We work now with smart hospitals and whatnot. And I think like, you know, finally, I was in a meeting today and I made a bet with a guy who said that, you know, he didn't see the need for edge. right? So like cloud, why? I don't understand, edge native applications. So I made a bet with just $100 that, when he finally realizes, that this is the way to go, he's going to pay me $100. So I'm hoping that's going to be very soon. But yeah, thank you so much. I'd love to take any questions if you have any.
Thanks, Nicholas. And I think we want to finish at the end of the hour, but we'll schedule with you, and you'll be able to do a full presentation and show the project and talk specifically about what you're doing in smart homes. I would just say that I had a similar discussion today with a smart energy company that told me, well, we move everything to the cloud, and after they saw our demo, they changed their mind. So same insight today. Okay, from here, let's invite Marcus from Novity to say a few words about his project.
Yeah, thank you, Moshe, and thank you, Roy, for a great presentation. So second Swede in a row here, which I'm sure is a complete coincidence, but there you go. So I'm founder and CEO of Novity. We're a predictive maintenance company spun out of Xerox PARC, based in Silicon Valley, that focus on process industry operators and helping them get accurate remaining useful life estimates based on machine condition for process industry machinery, compressors, motors, pumps, and so on. And getting the data out into the cloud for particularly large global multinational kind of super major operators is always a huge challenge. And so we're very excited to begin working with Moshe and the team here to deploy our solution on top of EdgeLake and AnyLog. So we're going to coordinate a more detailed presentation in the coming weeks to demo that and show what that looks like. But the preliminary results here are incredibly promising, and so I think we're onto something quite cool and quite big together. So it's something I'm quite excited about continuing to work with the team on here.
Thanks, Marcus. And another trail is another very cool project that we're doing, but I'm not sure who's here from the team.
Lionel is here.
Oh, great. Hey, Lionel. So yeah, please give us a few highlights of the project.
Yeah, hi. So we've been deploying EdgeLake on the so we are managing electrified boats here in the French Alps. So they are running cruising passengers on 2 lakes. So these boats have been electrified from petrol-based engines, and so the electrification creates some challenges on the way to exploit the boats the best way we could, especially on the battery lifetime and the lifetime expectancies. So we are using some data loggers coming from the vendors. So we are managing multiple vendors, aggregating the data from these different vendors on the I would say a single database and a single data form, so that they can be exploited for current commercial proper usage of the boats, and for the future, for like I said, the battery lifetime that we expect to last for 5, 6, 7 years, and we know it's going to be a challenge. So we expect the data that we are going to consume from the boats will be managed in some ways directly or through some eventually federated learning or distributed learning, so that we can exploit the AI engine the best way we could. So very promising.
Talk about truly distributed edge processing. So now we're literally sitting on a boat.
Yes.
In the middle of a lake. So it's an excellent use case for what EdgeLake can do.
Float the boat on EdgeLake.
Yeah, thanks a lot, Lionel. And from IoT Plus, I think Pi is here, and would love to hear a little bit about what you're doing.
Absolutely. Thank you, Moshe. A lot of learnings in the call today, so thank you for inviting us. We are an industrial IoT platform that we have a drag and drop no code environment which accelerates an end-to-end IoT solution deployment. We are based in Houston, so we do a lot of work with oil and gas companies. We also have some customers in mining and metallurgy space. And I'm glad to be working with EdgeLake, and we have started integrating our no-code environment to be able to drag and drop and integrate with EdgeLake. And I'm really looking forward to showcasing that work in one of the subsequent calls.
Yeah, great.
Thank you.
Thanks a lot, Pi. Yeah, I think we've reached the top of the hour, and I think we've covered what we planned to. I'm sure there are lots of questions and a lot of ideas and comments that people would want to share with us. So again, we would love your feedback, and please reach out to us. And thanks a lot. One comment is, if for people to be in sync with the TSC meetings, please register on the EdgeLake page. There is a place where you could register, and so all the notification about upcoming events you would get in from the Linux Foundation system. That would help us a lot and would keep you up to date with the next meetings and presentations that we will be doing. Thanks a lot for being here, and thanks, Roy, for a very great presentation. Thanks. Bye-bye.
Thank you.